So next I will be talking about some of the state-of-the-art techniques in machine learning. So what we have been doing for the past, I cannot say we because my research is not entirely on computer vision and machine learning, but sure, I can be part of the community. So the fun thing is, if you did not follow some of the concepts earlier, I would suggest you stick around because this part will be a bit more fun, and hopefully you understand what's going on in this part as well. So right, the first state-of-the-art technique that I wanted to talk to you about is image detection on unknown data. So this prototype or the image that you're seeing right now, the very vibrant image is that of Detectron. I should have put it on loop. So this Detectron is Facebook's AI research. So if you know, Facebook is not only a social media platform right now, it has taken over Instagram, WhatsApp, everything. But despite that, it's investing into so many things. So one major thing that it's trying to do is in its computer vision research or in the machine learning research. They're coming up with their own specialized cameras, virtual reality system, augmented system, and so on and so forth. And some of the work that they're doing is really cool. So Detectron is one of them. It's their flagship image detection system. Now we're talking about object detection. So earlier I was talking about image classification, if you remember. So we have images of cats and dogs, and then so you try to find whether it's a cat or a dog. Versus over here, I'm saying that okay, here is an image, parse the image for me. So it is giving you exact bounding boxes corresponding to a person. So it's saying person 99%, person 100%, bicycle 97%. So you see, it's now breaking up the image into pixels and giving you exactly those pixels which correspond to a bicycle, a person, a backpack, and so on and so forth, right? So it's so effective. So this is the link for Facebook's Detectron. You can go ahead and check it out. So the thing with Detectron is it is a system which does so many things. So it finds out the different person, it gives you the bounding box, it gives you their poses. So this is them doing the pose detection. So it is giving you like a stick figure and showing you where the limbs and joints are, right? So this is like an accumulation of 5 years of research for Facebook and Microsoft and stuff like that. So there are like tons of papers which relate to this. But I did not go, like, I am not explaining everything, but I just want to give you a brief idea of how the detection part is working. So the first paper in this field was RCNN paper. This, I think, it was done by Gishwis, or I'm not sure if I'm pronouncing his name correctly, but he was in Microsoft at the time and he made this paper. Then he transitioned into the FAIR project and Facebook. So what they do is, this was like a early 2015 paper. What they do is they take the input image and perform a selective search and generate all these different bounding boxes. And out of these bounding boxes, they only select those ones which has a very high probability of containing an object. Like after they have found the binding boxes which contain objects, they pass it on to the PNN or the convolutional neural network and train this convolutional neural network. And they had another machine learning system which tells you whether this bounding box was a person or a TV monitor and so on and so on. So that was their first paper, what they were trying to do. Now it got advanced from RCNN. We had faster RCNN, then faster RCNN. So these were papers in different years, so 2015, 16. And then finally this was Mask RCNN, which is their most advanced state-of-the-art work. So what this does is, instead of telling you a bounding box, it will give you a pixel to pixel ID saying whoever, like what does this pixel belong to. So it's a very more accurate kind of technique. So what they do is, they have, on top of all this architecture, they have a separate stream or a separate training algorithm going in parallel. It gives you a binary mask on the image which tells whether a pixel is a part of an object or not. So that's the kind of, so they have two parallel lines of training going on, and that's why they are able to figure out things with so much accuracy. So right, so some fun stuff. Let's look at a video of how Detectron is in action. So this is actually a scene setup, and they have
about drawing the bounding box around each object in the scene. Today, however, with the advance in computer vision algorithm, we are able to do much more than that. Our models now can localize key points of view.
So yeah, this was the step where they can find the joints, the joint positions, and key points, and give you an action of what the human is doing. So whether it's running, walking, stuff like that, and even for animals that can be done.
Human, it can predict their poses and label each of their body parts. This is also called density prediction.
Right. So that was how the system works. So this is actually part of a TED talk by one of the authors of the paper. So if you just type detect on to TED talk on YouTube, I think you will get this video. So look up the whole thing. It's very interesting. They haven't gone into anything technical, but they just give you a demo of the how the things work, and it works pretty well. And like I worked in the open source code as well. It's insanely well, and like you can even take videos that you have taken yourself and run it on the system. It will detect everything from you.
Object detection.
All right. So the next state of the art technique that I wanted to talk about is YOLO. So YOLO stands for not you only live once, but you only look once. This was also a very popular technique in the sense that it's real time. So that means it does not need any chaining process or like a cycle of feed forward and backward like we have been talking, but it will just go through the entire architecture in one swipe and tell you everything what is there to know. So what it does, what this guy is doing is it's taking the picture, and it's a clever neural network that breaks it up into smaller boxes initially, and then it is trying to find that whether these bounding boxes, what is the probability of these bounding boxes having belonging to a class, or whether what is the probability of say this box to belong to a dog, this one belong to a cycle, and so on and so forth. And then finally you can see that it gives the, so whichever are the thicker bounding boxes, those correspond to either a car or a dog or a bicycle and so on. And so it's giving you these probability maps, right? And then for individual boxes also, it's giving a threshold saying that okay, I think this guy belongs to a dog. And then it's like sort of matching or fusing these two boxes to give you the final detected bounding box output, right? So they do something fancy called non-maximal suppression that tells you that if a box belongs to both a cycle and a dog, then what is the probability that this guy is a box, this guy is a dog and not a box? So only once, which is in the name, you only look once because there is no iteration, so no feed forward and backward. And I think this is the strength of YOLO, which means it can perform real time. So if you just install it with a webcam, which is like taking videos of the street, it will tell you in real time what the different movements are. I think this is where we go into an ethical state because so YOLO have been put into use by a lot of people. So the Taiwanese government has put into use, and it was in the news because they are saying that they are trying to track everyone. So it means instantly you can identify the person in the image and see what their details are and so on and so forth. So the government can actually track its citizens based on YOLO. So that's a bit scary. So there was a lot of noise for that. And then YOLO is also used by BMW for their automated cars and other kind of driving sensation things. And Amazon has actually been using this to find whether you're socially distant. So in COVID-19, they implemented the YOLO V4 protocol to find out whether you are following social distance and so on and so forth. YOLO is very much in use right now, and it's working pretty well. Right. So go out and check this thing, and I would say you check the V4 version, not the V5, because there came out a yellow V5, but it's not from a very credible source. And V4 is by the original authors. This is the V4 section. You can go and check it out. So again, let us look into a demo because that's always fun. So this scene is from India, by the way. I think the authors took some video from Indian footage, and they had videos from the Indian railway system as well. So if someone can detect like images from the Mumbai railway, I think that algorithm works really well, like in a crowded railway system, right? So you can see it's giving you the bounding. So the difference between this and the previous algorithm I showed you is it will only give you the bounding box and not like a pixel-wise identification. So pixel-wise identification requires training. It's not without like looking only once you cannot. So this is that part. So this part ends the talk on sort of object detection and finding objects. So let me move into a different kind of topic that neural network people have been doing a lot. So I think you have heard of deepfakes, and it's used as memes in Facebook even these days. But let us look at this one for an introduction of what is going on.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or how about this? Simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. It's a time when we need to rely on trusted news sources.
It helps in relating the message. So again, President Obama never said none of these things, and this is like actually an image footage of him, and then it was worked on in that sense. And I think there are like apps where you can put your faces on Bollywood actors. Some of my friends were doing it. So it's amazing to see how they're using deep learning even in like childish things. They've come a long way, and it's almost scary, like you said. So how is this thing done, right? So this thing uses something at the back called the General Adversarial Network, or GANs. So GAN was actually invented by Ian Goodfellow, who is one of the founding fathers of machine learning, modern day machine learning, if you may. And what GANs do is, so they have two things. So they have a discriminator and they have a generator. The job of the generator is to, given any random input, generate a sample for me. Right? So the discriminator has samples coming in from the generator as well as samples coming in from the real images. And its job is to discriminate between the real image and the generator and say that, okay, I think this is fake, this is real. So in this case, the discriminator finds this thing as real quite easily, while this is what the generator had generated and saying that, okay, this is fake, this is real. In the second iteration, the generator, on getting rejected with its initial idea of a $10 note, performs a better estimate and generates this $10 note. And the discriminator is still able to distinguish between a real and a fake and discard it. Finally, after tons of these iterations, the generator is actually able to generate something which is more realistic, and then it gives you this $20 note, and it's able to fool the discriminator, and the discriminator thinks that whatever was generated by the generator is real as well. So this is the kind of iterative process where the generator is trying to fool the discriminator, and this guy is trying to just find out whether it's a real or a fake. And the moment it cannot distinguish between the two, we say that the network is trained, and we can actually generate fake data using a generator, like it was done for the Obama video. Generative adversarial network is a very hot topic right now, and it's being used in even medical domains, drug discovery domains, and stuff like that. But in computer vision, it has actually stoked some flames, if you might say, because there are videos of like this, which belongs not only to President Obama, but Trump, Putin, and so on and so forth. And there are so many possibilities you can do. Right. After that part, let me show you some more work of adversarial network. So this was one of the paper as well that came out of StyleGans. What they are doing is they are taking the image of, so they are taking some famous artwork. So this may be a Picasso. So they are taking these artworks and they are taking images of real things, so bridge, Brad Pitt and Lena and so on and so forth. And they're mixing these two images to give you like artistic images as an output. So as you can see, this blend is so like realistic. So this is actually Brad Pitt, but the style comes from this image. So what they're doing is they're taking a style image and they're taking a real image, and so I haven't discussed encoder decoder, but it's okay. We can get away without discussing that. So you have an encoder and you pass the style image and the real image, and what this encoder does, it essentially maps it into a latent space. So a latent space is just a fancy space where it's easier to do mathematics and the maths hold. So it's transforming it to a different domain from the image domain. On that domain, they do something called the adaptive instance normalization. I'm not going into the maths of it. So actually this guy fuses these two styles in the latent space, right? And the decoder again brings down the image from the latent space up to your image space, and then this is finally the output that you get. Then they're computing two things. So remember loss functions, we were talking about loss functions. So they're computing the LC, which is the loss for the image, and then LS is the loss for the style. So they're counting how much loss they have from each of these two, and they're trying to minimize both the loss from the image as well as the loss from style. And once that is done, we get these kind of outputs. You can look up the paper. There are many more examples which gives you like realistic artistic images of the input, right? So that's pretty cool. All right, so the next work, this is NVIDIA's stalwart work in the field, and if you ask for my opinion, it's a bit scary. So what they're trying to do is they're trying to find styles in an image. So that means there's a core style they have to find for facial images. They're finding the pose, hair shape, and so on and so forth. For finer styles, they're finding facial features, eyes, age, and that kind of a thing. So that means, so suppose this top row is your source A. So from this source, it will take the gender, the age, the hair length, glasses, pose, and so on and so forth. And from source B, it will take everything else. Now what they're doing is they're fusing these two images and generating these images. So if you fuse these two images, you get this one. These two images, you get this one. Fuse the image of a baby with her, you get this. So the scary thing is all these four different persons, they do not exist in real life. So these are synthetic data that was generated by the neural network, and there is no existence of these people. So here's one more example. There is no example of these people as well. It's just the fusion of these two faces or these two faces. And it's kind of scary to see how realistic they are, but they have no existence in real life. This paper by NVIDIA uses this module as well that kind of fuses the style and the pose and all these things together, and you can actually tune the parameter. You can say that, okay, I will take age from this guy, but not the glasses or not the hair. I'll take hair from her. And then create your own artificial human image, honestly, right? So this is what this StyleGan paper was doing. So these are all unsupervised learning of higher level attributes, and the stochastic variables in the images, that is freckles, hair, can be nudged and changed. And this is done by, like, again, they have an encoder, they move to the latent space, and then this guy cleverly fuses the styles together by learning them separately. So that was what this paper was doing. All right. So for my next paper, I have this few-shot learning. So remember when I talked earlier about the things which is, so one of the disadvantages of machine learning was that you need a lot of data to train whatever network you're doing. So this paper by, say, the deepfake paper, not Yolo is out of that, but Detectron, deepfake, these kind of things, all of these need tons of data, like 10,000 image faces at least to begin with. So that can be a challenge. And the point is big players like NVIDIA, Google, Facebook, they can get their hands on so many data because Facebook has all the data anyway. I know it's not ethical or so, but the problem with that is when we are working with it, we might not have so many data, right? We might not have 10,000 data to begin with. So what do we do? So in that sense, few-shot learning is something which is becoming very important and becoming very relevant in the sense that, so what you can do is, so these, I think 1, 2, 3, 4, 5, 6. So these 16 images are 16 selfies that were taken of this person. I think she's one of the lead researchers in this paper. So when you have these 16 images, you can actually learn the face from the 16 images. And then when you have this video, so you have this video of her talking, it finds the landmarks and it projects it onto this image. So this image was never moving to begin with, but where, like, her video mapping of the landmarks were mapped onto this image, and you can actually, from just 16 images, you can do this kind of a stuff. Now the cool part about this is you can map it into someone else. So you just don't map it into your face. So this is a picture of a Marilyn Monroe, not of the Marilyn Monroe, and they have mapped their facial movements on top of this image. And you can see the results are fascinating to say the least. And then this is done from just a single image, right? So they had tons of video footage to train their data. So this is Salvador Dali. You can see his moving face as well. So I don't think there are actual video footages of Salvador Dali. Let's go a bit forward. We have Albert Einstein over here. And then, so this image is first of all colorized, and then they gave this lip moving thing. And then the most creepy thing for me was Mona Lisa talking. They had someone talk, and then they mapped the facial landmark features, and they made the portraits move in that sense. It's actually, there are two things to it. So first of all, you need the video to train the network. So they have trained with tons of video. And then finally, when you need the portrait or when you need the image to work on, then you can just work with 1 or 16. So that's an advantage. But the disadvantage is you still need tons of video footage in order to train this network. and they have used generative adversarial network again to train their thing, right? So they need the metadata of lengthy amount of time of people talking, so that pick up all the facial features, and then they do the landmark detection, as you saw in this thing, which is like mapping nose to nose, eyes to eyes. So if you see, actually bulge their eyes over here, and you can see the eyebrows are raised, and in the output image as well it's raised. Whereas in the input image, there was no image where the eyebrows are raised as such. So you can do these kind of things. So next part for some takeaways and links. So if you want to go ahead and do your own thing, this slide is sort of more like my take on the thing. So evolution and current trend. So the thing, so the first bullet point, the thing that I've seen in many of the CVPR or NIPS conferences where representatives from say Google or Microsoft or NVIDIA, they come and give their talk. Whenever they're talking about training, or so for instance, Google's new BERT architecture that works on like trillions of data. So if you're working for someone who is not a Forbes 50 company, it's not likely that you will get trillions of data, right? Not especially for startups, it's hard to get your hands on trillions of data, and then also work on a system which is like in petabytes or in very high Google Cloud, which the bigger companies can afford. So these newer technologies are few-shot learning with less images, with this lower architecture, but still do important thing that's become very important. So that is where I feel the research will shift towards in the next few days. And now you can do deep learning even in your mobile phones as more and more better algorithms are coming in. And then the one more good thing about this community is that everything is online. So remember Detectron, the paper, the code, everything is online, and you can just look it up, hack it, make it your own, customize it. Same thing goes for NVIDIA and everyone. So ImageNet is actually a repository of images, and that is like hundreds, thousands of images in like cats, dogs, and tables, chairs, and so on, you name it. So you can do any kind of image-based computer vision, machine learning jobs by downloading ImageNet, and it's free, of course. So these online repositories, these online GitHub links, they help a lot in your learning process, training process, transfer learning. So transfer learning is again a heavy beast where you pre-train your network based on some images, and then you use it for your customized thing. Again, if you're working on something specific, for instance, you're working on finding tumor in a brain data set, or you have a very specific problem of this kind of metal. So people in metallurgy have been looking at machine learning and seeing, can we figure out what is the melting point or stuff like that from the image. Those kind of images are hard to get your hands on. So that kind of domain, cross-domain scientific research is still a bit hard, I feel. But in general, if you're working on like normal computer vision systems, I think it should be pretty easy to get your hands on most of the repos and just start working on it. So next is some of the starting points some of the pointers I wanted to throw at you. So starting point for neural network is again TensorFlow and PyTorch. There are tons of other coding methods out there. You can use Caffeine. There is PyMC3, there is a whole beast of Gaussian neural network and stuff like that. But if you are looking for a starting point, I would suggest you go for TensorFlow, not even PyTorch, simply because it's easier to understand and there are tons of examples. It's explained well. So yeah, PyTorch is also pretty good, if I may say. And so yeah, these are the two things that they will tell you what exactly to install, what to work on. So you will have a pretty good understanding. And then you can look at Andrew Ng's course. There are Stanford lectures which helps you. I'm sure if you type anything, what is machine learning or those kind of questions as well, there will be pretty good blog posts in Medium, Machine Learning Mastery towards data science. So these are the 3 blogs that I have mentioned, because these are actually maintained and the authors are people who are working in the industry or as professors, and they are like working on the state-of-the-art work, and they do a very lucid job of explaining concepts or simpler concepts, complicated concepts, images, diagrams, and storytelling. So you check out these blog posts, I think they'll be very useful. And then you need a general acquaintance with open source. So that means like whenever you're working with these kind of ImageNet and these kind of things, there will be bugs in the code. You need to understand how to work with someone else's code, download it, install it on your own system. There will be version problems with that, so you may have to sometimes ping the author, but these comes along with the thing. So if you get good with open source, that's one way you can get good with machine learning and this community in general. And then final thing which you can learn, this is not a starting point for sure, but eventually is CUDA. So because the trainings, if you train with larger networks, it becomes very slow. So if you use CUDA, they utilize the graphics system or the graphics card that you have on your system, and CUDA does it. It splits it into like parallel processing. And so if you know that, you might be able to like train your network much quicker, maybe 10 times quicker, as opposed to like a normal TensorFlow without the GPU support, right? So this is something you can look up. So having said that, these are some of the opportunities that we can look into. So there are like opportunities means opportunities of applications of machine learning and computer vision. So for human, it's hand, body, face detection. In the industry, of course, it's used in food manufacture. I was actually contracted by a company called Check, who have shipping containers. So they're trying to take pictures of shipping containers to see if they're damaged or not, and do it in an automated process. It's tons of manual labor where they have to look into all shipping containers and find out what's the problem in that. So fish tracking, agriculture, harvest control and stuff like that, especially in the US, where there is like tons of acres of field where there is no one looking at it. You can actually have a drone, and then that drone takes picture of your crops and everything and tells you whether the crop is healthy or not. So again, tons of applications. So for job opportunities, again, the top 50 tech companies are always looking, and they're expanding their computer vision and research team. Tesla is one of them as well. So Google, Amazon, Facebook, Nvidia, even in Microsoft and Bosch, their Indian versions are looking for people in computer vision. I cannot find my mouse pointer, but anyway. In medical vision, Siemens is a major player that are looking at these medical data. Eli Lilly is actually a big company in drug design, medical vision, and these kind of things. And they are recruiting in India as well. And there are tons of tech startups that are working on autonomous vehicles, virtual reality technology, augmented reality technology, headsets, gaming industry, and those kind of things, which are hiring as well. And then again, if you learn computer vision, machine learning, the general data science roles, which are like immense. So in insurance to car to everything, they also give you an opportunity because you have worked on machine learning architecture in general. The scope and job opportunity, the market is, even in the pandemic, it's pretty booming. So yeah, you can definitely check that out. Right, so finally, these are some of my references. So these are the blog posts. Go and check out TensorFlow. Go and check out Stanford's notes on computer vision. And then these are the papers that I talked about in my talk. And so ICCV, so you can actually, if you feel like, okay, I'm too bored to read papers, maybe you can go to so ICCV NIPS. So NIPS is a good conference, ICCV is a good conference. They actually have their talk in YouTube. So you can follow the talks and then they follow the presentations, and that way you can keep in touch with what are the latest trends on YouTube, right? And you don't have to read boring papers. So yeah, that's it for the references. So that's it from my side. Thank you so much for being attentive and listening to me. Okay, by the way, if you guys don't know her, she's a robot from Singapore, a company in Singapore. Her name is Sophie. She is actually quite good at what she does. She has a vision system and everything in her. So follow one of her interviews. So she's a humanoid robot. This was on a visit to India, in Kolkata, India. So thank you, everyone.